Welcome back to your free Windows 7 training course. Regardless of whether you use IP version 4 or IP version 6, you are going to at some stage need to perform some network troubleshooting. The first command I will look at is ipconfig. ipconfig is a powerful command line tool that provides a lot of information about the network adapters on your computer and how they are configured. If I run the command ipconfig with no arguments, I can see the basic configuration for each adapter installed on this computer and also any virtual network adapters. This computer has 2 network adapters installed and also VMware installed. Any virtualization products, such as VMware, will create additional virtual adapters. Notice at the bottom you also have the adapters for ISATAP and Teredo. If I scroll to the top past all the virtual adapters, you can see the basic configuration details for the 2 network cards installed on this computer. This will give you basic information such as the IP address or addresses for these network cards and their subnet mask and gateway addresses. If you need to get more information about your network cards, you can add the /all switch. I'm also going to add the filter and more argument. This will pause the display after a screen full of information is displayed. At the top of the screen, the host name is displayed, plus other information such as the DNS suffix. The next section will tell you about the physical network adapter installed on the computer. Some of the information has been cut off, so I will press the Enter key to scroll down a couple of lines so all the information for that network adapter is shown. Besides basic information such as the IP address, DNS server, subnet mask, and gateway, there is also information such as the physical address of the network adapter. This is also known as the MAC address or Media Access Control. If you decide to create a reservation in your DHCP server so that this computer always gets the same IP address, you will need to enter in this MAC address into your DHCP server. To see the remaining information, I will press space to scroll through one page at a time. The next command I want to look at is ipconfig/release. This will give back any IP addresses that this computer has leased from a DHCP server. If you want to do the reverse and get an IP address from your DHCP server, run the command ipconfig with the /renew switch. If one of your computers on the network changes its IP address, you may have a stale cached DNS record on the computer. If this occurs, you can run the command ipconfig with the /flushdns. This will remove any cached DNS records on the local computer and force the computer to resolve the next DNS request from the DNS server. If you change the IP address on this computer and you are using dynamic DNS, the IP address registered on the DNS server for this computer will be incorrect. To fix this, run the command ipconfig/registerdns. This will force the computer to register its host name in the DNS server. Notice the message telling you that the request has been started, but may take up to 15 minutes to take effect. The request should go through straight away. However, if the computer cannot contact the DNS server, it will wait and try again later for a period of up to 15 minutes. The next commonly used troubleshooting tool is the ping command. The ping command sends a packet to another computer or device on the network, asking it to inform the sender that the packet was received. The device, if configured to do so, will then send a packet back, telling the sender the ping was received. Devices such as firewalls often do not respond back when pinged. The ping command works with IP version 4 networks as well as IP version 6 networks. For example, if I ping the IP version 6 address for Google, the ping command will send 4 packets to Google from which it will get 4 packets back. The ping command also measures the round trip the packet took, that is, the time taken to arrive at its destination plus the time it took to come back. In this case, the DNS record returned will be an IP version 6 record, so Windows will automatically use IP version 6. If I ping DC1, which is domain controller on this network, you will notice that Windows will also use IP version 6 to communicate with this server. However, like a lot of commands in Windows, if I add the -4 switch, this will force the ping command to use IP version 4 when pinging the host. IP version 6 would also be used if I added the -6 switch. The ping command by default uses a 32-byte packet. Measuring the time it takes for this packet to return gives you an idea of the latency on the network. If you want to test the network with a bit of data, you can add the -L switch and the size of the packet you want to use. In this example, a 4K packet will be sent over the network. When troubleshooting problems on the network, especially networks connected to VPNs, it is worthwhile testing the connection with a large packet. VPNs encrypt packets and then check the packet on the other end to see if it is the same. If you have a router in between that cannot handle a large packet size, it will split the packet up into smaller parts. The VPN on the other end will think the packet has been tampered with and will discard it. Using the -L switch is a good way to determine if large packets are getting through. If a router between you and the destination attempts to split the packet up, the ping will fail. The last switch I would like to demonstrate with the ping command is the -T switch. This is what is called a constant ping. The ping command will keep pinging the other side until you press Ctrl+C or close the command prompt. When I reboot servers, I like to perform a constant ping. When the server starts shutting down, it will initially still respond to pings. While the server is starting up, it will not respond to any pings until the networking on the server has started. Once the server starts up again, it will respond to pings again. If you always get ping responses back, then the server probably has not rebooted. Most likely, an application on the server will not close and is stopping the server from rebooting. If the pings stop and don't return, perhaps there is a DVD in the server and the server is attempting to boot off of it. Either way, performing a constant ping lets you know there was a problem when rebooting the server. When performing a ping and you don't get a response at all, then you may have a network outage somewhere. To find out where this outage is, you can run the command traceroute. The traceroute command contacts each router between you and the destination. For example, if I attempt to run a traceroute to google.com, you can see all the routers between me and the destination. As traceroute goes through each router or hop, traceroute will attempt to resolve the IP address to a host name. You will notice that as it goes through each hop, if the IP address can be resolved to a host name, it runs quite quickly. If the IP address cannot be resolved to a host name, the computer appears to stall while traceroute is waiting for response from a DNS server. If you want traceroute to run faster, you can disable the resolving by adding the -D switch. If I run another traceroute, you will notice this time it runs faster as it does not need to wait for a response from the DNS server. When traceroute runs, it will test each hop 3 times and record the time taken for the response to come back. If it fails to receive a response back, the time will be displayed as an asterisk. If your packets go through a firewall, the firewall may block the return from ping and you will get an asterisk in all columns. The last command I want to look at is the netstat command. The netstat command shows the active connections from your computer. When troubleshooting, it is helpful to know what connections your computer is making to other computers. The netstat command also shows the port that is being used. The last column shows the state of the connection. Netstat is particularly useful if you think that there may be malware on your computer. Any connections opened by malware will show up here. If you add the -A switch to netstat, you can see which ports are open on the computer and waiting for connections. This is a quick way of finding out which services are running on a computer. Finally, if malware has installed itself and opened a port up on your computer, it will show up here. This concludes troubleshooting the Internet Protocol. In the next video, I will look at configuring wireless devices. Remember to have a look at our webpage for more videos, study guides, and exam questions.